So here's a question that I wanted to take a look at with you, and it involves finding the equation of a line tangent to a trig function. Okay, and one of the things that I want you to realize is that when you've written equations of lines before, if you ever took an algebra class, you've done this where you have y minus y1 equals mx minus x1. Okay, and there, I think some of these may have popped up in videos prior to the one that we're doing now. So we need an x and a y value, but we also need the slope of that tangent line. So there's a couple of things to keep in mind here. As we go throughout this problem, we need to know the slope of the tangent line. And hey, how about that's a derivative, right? Find the derivative in order to find the slope of that tangent line. The other thing that we need to know is a y value. In this problem, we know that the x value is pi over 6. So if I wanted to know the y value, then I would simply plug in pi over 6 to our function. And that's what we've done here. We've plugged in pi over 6. You can use the unit circle. You can use your calculator. The sine of pi over 6 is 1/2. So we have a coordinate to plug in over here. We've got y, and I like to use the colors. I think it helps identify kind of what's what, right? So we got y minus 1/2, okay? That comes from this thing. And over here, I don't know the slope of the tangent line, but I do know that the x value is pi over 6. To find that tangent line slope, excuse me, I had a battle of sneeze. So to find that tangent line slope, I'm going to take the derivative of our function. The derivative of sine is cosine, and I'm going to plug in pi over 6 for x. So again, using the unit circle, we can figure out where that x value is, right? Remember, with the unit circle, cosine corresponds to the x coordinate. So I know that the slope of my tangent line is the square root of 3 over 2. Now this is going to make for a very, very weird looking answer. We have y minus 1/2 equals the square root of 3 over 2x minus pi radical 3 over 12. So if we were to go in and simplify this a little bit, we would have the square root of 3 over 2x minus pi radical 3 over 12, and we're going to add 1/2 to both sides. And that's where we get this thing right here. Here's another problem extremely similar to the one that we just did, although what makes this one more difficult is that we have a co-function, right? We've got the cosecant of x this time as opposed to just a simple sine function. So we're going to begin by finding the value of pi over 2, okay? So we have the cosecant of pi over 2. Now look, the PowerPoint just says that the cosecant of pi over 2 is 1. Let me give you a little background. Cosecant is the same as finding the sine value and flipping it. So the sine of pi over 2 we know is 1. We base that on the unit circle. Okay, so pi over 2 is up here. And if I flip 1 over 1, I just get 1, right? So I already know some information. I know that my y value is going to be 1. So we'll have y minus 1 equal, I don't know that slope, but I do know that the x value is going to be pi over 2. Okay, so our job then is to go in and find out what is the slope of that tangent line. And in order to do that, we need the derivative of cosecant. Well, the derivative of cosecant is negative cosecant cotangent. So let's take a look at how we evaluate negative cosecant cotangent. One way is to plug in a bunch of sines and stuff. Well, you can do that, or you can remember that we've already found the cosecant of pi over 2, right? We already know this value is 1. Well, there's a negative out front, and that gives us a negative 1. Now we really just have to worry about finding the cotangent of pi over 2. So if I want cotangent, I can just find the tangent of pi over 2 and flip that value. For tangent pi over 2, you ought to remember that we have an asymptote. Okay, so there's an asymptote at pi over 2. And because there's an asymptote at pi over 2, that is a place where we have a number divided by 0. right? You got to go back to some math classes of old in order to figure that out. So to flip 1 over 0 would be to say 0 over 1, right? If I'm going to flip that, and 0 over 1 is just 0. You could also do this problem the way the book has it here. The cosine of pi over 2 is 0. We're basing that on the unit circle. So 1 times 0 is 0. All that to say that the slope of our tangent line is 0, and that gives us an equation of our tangent line to be y equal negative 1. Okay, all of this is going to apply regardless of the function that you're looking at. So if it's a trig function, or if it has a chain rule, or if it's a product rule, or a quotient rule, e to the x, they all work the same way. So you're going to begin by finding that equation of that tangent line, and then you're going to plug in an x, a y, and the slope of the tangent. And the slope of the tangent is where we take the derivative.